Do you want to know how real rooms interact and affect the bass response of your loudspeakers? That's what we're going to be talking about in today's video. Hey folks, I'm Gene Delasella with Audioholics. I wanted to talk to you guys about how loudspeakers interact with a real room, how they enhance or how they change the bass response. Because more often than not, you look at the manufacturer's specs or you look at their anechoic data of a loudspeaker, and I hear people online saying these speakers are not flat to 20 hertz, or they just roll off too soon. They don't have a lot of bass. That couldn't be further from the truth in most cases because the loudspeakers in the anechoic response don't factor in the actual gain you get in a room, which could be pretty enormous. So you can get really low, deep bass extension if the speaker is properly designed and it has the dynamics and it has the output capabilities to support giving you that bass extension and giving you that at meaningful SPL levels. So I asked James Larson to help me put together a little slide presentation here on how room boosts the bass of your loudspeakers. And we're going to be showing you some examples here, doing a little bit math, not much, but hopefully it sheds some light on this topic for you guys. So the first thing is in normal domestic rooms, low frequency reproduction usually becomes elevated relative to high frequencies due to two acoustic mechanisms. So number one, you have a pressure vessel gain, and that's what we're going to be talking about, how the speaker will actually interact with the room to give you a certain amount of increased bass level, depending on the bass alignment of that speaker, as well as the room dimensions and how much gain you get in that room. And then the other is boundary gain. That's when you put a speaker close to a surface and you get extra bass boost at those frequencies, depending on how many surfaces are near that speaker. So a pressure vessel gain, we'll start with that one. When the room dimensions are shorter than the pressure wavelengths of the sound, the lower wavelengths summate, thereby elevating the lowest frequency output. This begins to occur where half the wavelength cycle is equal to the longest dimension of the room. The gain occurs usually at 12 dB per octave rate, and a lot of that depends on how lossy the room is as well. If you have infinitely rigid walls, or you have walls that flex, or the room is open to another room, you're not going to get as much gain. With a 14-foot dimension, this room is as long as half the cycle wavelength of 40 hertz. So it will start to accumulate bass at 40 hertz. This is a very simplified example, obviously, where the wavelength is the speed of sound over the frequency, but you can see here how this idealizes the room gain you get from it. Basically, what this tells you is, and when the bass wavelengths are longer than the dimensions of the room, that pressure builds up and it amplifies those frequencies, and you get more gain as a result. And I have the perfect example in my theater room. It's 25 feet long by 20 feet wide. And if you think about the 25-foot dimension and you use this principle, I get tons of gain at like 22 to 25 hertz. And even with all the subs that I add, you still have all that gain from those dimensions. And I have to go and use EQ. I have to go and make sure each seat gets very consistent bass. That way the equalization works for all the seats. So I could get rid of the extra bass by cutting it with EQ, flattening out the response and giving you more linearized sound. So boundary gain is the next one I want to talk about. Boundary gain is the increase in the acoustical output that happens when a sound source is restricted by boundaries like walls, floors, and ceilings. Some people don't realize that the floor actually serves as a wall and the ceiling serves as a wall. Very similar principles to your side walls, your front walls, and your back walls. It is technically frequency independent, but since lower frequencies typically radiate outward from the loudspeaker and subwoofers is much wider angle, they're usually far more affected by boundary gain. So that means that the bass frequencies are way more affected by the boundary gains than the higher frequencies in the loudspeaker system. Also, higher frequencies are more absorbed by many of the common materials than lower frequencies. So just stuff on your walls, some absorption, some curtains, stuff like that, that absorbs the high frequencies, but it doesn't absorb the bass frequencies because those wavelengths are really long. And in idealized acoustic conditions, boundary gain boosts output by 6 dB per dimension restriction. So here we have 4 pi, which is 0 dB gain. This is when you take a loudspeaker and you measure it outside on a pole, let's say a 90 or 100-foot pole. You put the subwoofer up there, there's no gain, it's in free space. But when you put it on the ground, what we do, we call ground plane, which is how we measure subwoofers. Because of the ground surface, you get a 6 dB boost of gain. You get 6 dB more output because it's an infinitely rigid, long surface. That's why we always have to subtract 6 dB if you want to know the true anechoic response. And the interesting thing is, eighth space is when you corner load a speaker, you get 18 dB boost. So you get 6 dB per surface. You got 3 surfaces. Some manufacturers will give you max SPL at eighth space. I've seen them Klipsch do that. Very interesting. So you always have to know how the manufacturer is specifying its output. Is it in free space? Is it ground plane? Is it eighth space? So anytime you put a speaker close to a surface, you're going to get some more boundary gain as a result. So an anechoic example of a loudspeaker equalized intended to compensate for boundary gains. We have this Cali audio that James Larson reviewed and measured, and you could see that they have different settings on the loudspeaker depending on where you're placing the speaker, usually the desktop speakers. You could adjust it with the EQ to compensate for those surfaces to give you a flatter, more linearized response for that application. So loudspeaker designers often try to compensate for low frequency gain by attenuating the low frequency response. So they're deliberately not giving you that flat output down to 20 hertz because they know that you're going to stick the speaker in a real room and it's going to get a lot of gain and it could potentially sound very boomy as a result. The common methods of attenuating low frequency gain is using a seal design which raises the system resonance but rolls off the response at a gradual rate, or over dampening a port system so the port output is lower in a level than the output of the bass driver. Now, something interesting about sealed designs, if you have a sealed system and it has lots of output and it has lots of dynamics, it has, a big cabinet, big driver, long excursions, even though you have less bass output per se above, let's say, a ported speaker's tuning, below the speaker that's tuned for ported, those tend to fall off at fourth order or 24 dB per octave, whereas the seal system falls off at 12 dB per octave. So in those cases, those really high excursion sealed subwoofers could give you more room gain, and you could get those single digit bass response in a room that's not so easy to achieve all the time with ported systems. So real world effects do not have the perfect math or gain modals. In reality, distance from surfaces or acoustic dispersion of speaker attenuates level of boundary. Many normal objects, such as sofas and soft materials, have acoustic absorption. You want a room that has mass in it. You don't want a room that doesn't have mass because then you have a lot of echo, you have a lot of decay. It doesn't sound good at all. So you definitely want mass in a room. And of course, anytime you add mass in a room, you're going to dissipate some of the energy of the acoustic output of your speakers as heat, because it's going into those mass devices and vibrating and exciting the molecules. Objects can also fill occupied volumetric area, thereby increasing pressure vessel gain. Objects near speakers can also reflect pressure waves, thereby increasing boundary gain. So if you put a speaker near a table or a glass wall, all that stuff is going to affect the output of the speaker, and usually not in a good way. So you want to keep those surfaces, those hard surfaces, away from the radiating area of the speakers. Walls, floor, ceiling, surface, doors, and windows can flex, and this can also absorb low frequencies. Give you a perfect example. I set up the system for my uncle, and they're Colombian. They like to have these massive parties, hundreds of people. And as the night goes on, the music gets louder. The alcohol is, people are drinking, and they just keep turning it up. His walls in his room were flexing. The drywall, I've never seen anything like this. The drywall was breathing. It was literally going in and out. And you just stick your body up to it. You feel it. Obviously, when that's happening, it's lossy. You're losing some efficiency of that system because it's going through the walls and it's radiating those areas. Real world acoustics are very complex. So let's take a look at some examples of anechoic versus reality for how loudspeaker designers compensate for room gain. So the Perlisten S7t, when you look at the anechoic response, you're like, this speaker doesn't look like it has a lot of bass. The 3 dB point anechoic is like 60 hertz on it. But when you look at it in a real room, like in my family room system, when I plug these speakers into my family room system, which is a large room open to a kitchen, I was getting a -3 dB point of 17 hertz. So these speakers have some really decent bass response and they have lots of output. That's the key. When a speaker has lots of output, you can go and you can gain up if you need. You could turn the bass up if you need to without worrying about distressing the system. The Arendal Sound 1528 Monitor 8. The 3 dB point on the anechoic response that James measured was around 42 hertz, but in room got down the 3 dB point of 16 hertz. These speakers have bass. The Monitor 8 bookshelf was giving me some serious bass below 20 hertz. I mean, these speakers just have lots of excursion. They're large speakers, and the Tower 8 as well. That thing shakes a room if you put it in the right room. A flat anechoic response down the port tuning often leads to unnaturally elevated bass in a room. We talked about this already. Many audiophiles seem to like elevated bass, but this cannot be called high fidelity. I'm going to have to disagree with James Larson on that. So if you have really linearized bass response and you want to tune that system to your liking, you can have elevated bass as long as your modes are in control. Really what it boils down to, in my opinion, is personal preference. Yeah, there are target curves that you could set. You don't want to overly excess, have too much bass, but it also depends on the room. It depends on the flooring. If you have hard floors versus a flexing floor, if you don't feel the tactile energy on your floor, you tend to need to elevate the bass a little bit more because you want to have that in your chest and you want to be able to feel the tactile of the bass. So a lot of that is preference. So I'm going to leave that as a little asterisk on that point there. Trade shows such as Expona are filled with rooms where the bass is out of proportion with high frequencies. I agree with James on that. There's been so many, it's not just Expona, it's at Cedia, it's at Florida Audio Expo, it's at Audiovice, all the trade shows I've ever been to. Some of the manufacturers will gain up those subwoofers, although boost the bass to ridiculous levels, sometimes 10 or 15 dB too high just for the wow factor. And that's not accurate at all. It gets actually pretty annoying because you don't get to hear the articulation of the bass, especially if they don't have the room modes under control, and it just resonates those frequencies and it becomes really grating to your ears. One loudspeaker that we reviewed was a Klipsch RP8000F, had very little attenuation at the port output, and as a result, it was boomy when placed near a surface. So you got to be careful about that. If you have a rear ported speaker and you put it too close to a boundary, you could accentuate that bass and have way too much bass around the port tuning, and it could get boomy. And you're either going to have to move the speaker, you have to plug the port, which I really don't like plugging the ports if you could avoid that, or you have to use some EQ to kind of gain that bass bump down. Damping the low-end response is a guesstimation to get natural bass and sound for typical room sizes. So large room sizes do not benefit from as much room gain as smaller rooms. So speakers with damped low end may sound thin in large rooms. And that's true. I've experienced that. I've taken speakers where they sounded great in a small room. You put them in a big open room and they just sound thin. Now, personally, I prefer bigger rooms because you have better modal control of bigger rooms and you could just add more subwoofers. And I tend to find in larger rooms, less standing wave buildup. You can control the bass response a little bit better, but you need more headroom. You need speakers that have the capability. You need subwoofers to have the extension and output to compensate for the larger spaces. So even a loudspeaker with damped low end can still have an over boosted bass if the room is small enough, since the small rooms can have a lot of gain. And I'll give you an example of that in a minute with Revel. If you want perfect, you will need electronic equalization to suit the speaker to the space. Electronic equalization is usually a good idea anyway to address room modes. Again, once you get multiple sources of bass in a room, like 2 subwoofers or 4 subwoofers, and you get consistent sound or consistent bass from seat to seat, that equalization becomes more effective for all the seats. So you can have a good experience for every seat. That's when equalization is really advantageous to get some of those bumps down, flat and linearize the response. Then you could boost the bass to your taste and it won't sound boomy. So I wanted to show you guys in this room, I had the Revel F328s in here for a couple of years. And I was really disappointed in them. I could not believe when I first installed them. I'm like, man, these speakers, they sound like no bass, really thin, very sterile sounding. I just did not like them. I wasn't thrilled with them. And I kind of just held on to them for a while. I didn't write a review of them. I'm like, let me try them in different rooms. So I brought the Rebels down to my music room downstairs, which is a much smaller room, which has a lot of room gain. And the speakers opened up. They had way more bass capability. They were shaking the walls. They had tactile response. The speaker sounded more balanced. So in this room, it's a problematic room because I have the speakers sideways in the room. It's just I have no other choice, and I can't add subwoofers because I've got a lot of stuff in here. I needed a speaker with more horsepower. So I brought in the RBH SFTR AX. It's an active system, and it's got dual 12s in a sealed cabinet, whereas the Revels are ported with 3/8. And the Revels have a much higher tuning frequency, and they drop off like a rock below 25 hertz. So you don't get much room gain at all with the Revels. You can see the difference here. The red is the Revel versus the RBH, which is the green. The RBH is just absolutely destroy the Revels in low-end bass response and tactile and output. I mean, these speakers sound, this room actually shakes, and it has so much more tactile energy because of the speaker I chose. The Revels were incapable of doing that in this room, whereas the RBHs were. But it took a lot of horsepower. It took, an active speaker system with dual 12s, 2 or 3,000 watts per speaker. So I basically used a nuke in this room to overcome the acoustical problems of the room. It's not that the Revel speaker is bad by any means, but I needed more horsepower in this situation. I could have done the same thing if I kept the Revels and added more subwoofers in the room, strategically located as well. So use room gain to your advantage to adjust bass level to your taste. We talked about this. It really boils down to what level of bass sounds right to you. What is the construction of your room? Because if you have a hard floor, like a concrete floor, you don't get a lot of tactile energy. I went from this when I went from my theater room, which was upstairs in my other house with, 2x8 rafters, versus my new theater room, which is on a first floor in a concrete. I don't get that tactile response that goes through your spine like I was getting in my old house. So to compensate for that, I had to add an infrasonic sub in my theater room, a 21-inch sub, and I have to boost the bass up a little bit more. In my other house, I maybe had boosted the bass 4 or 5 dB. In this theater room, 6, sometimes 7 dB, I boost it just because I want to feel that bass energy more that I'm not getting through the floor. So moving speakers closer to front walls or corners will elevate the bass response. Many may also elevate SBIR effects, which can be calculated by the frequency for that SBIR problem is the speed of sound divided by 4 times the distance, where the distance is the distance from the speaker to that wall. And I've seen this in my own theater room. So my SVTRs in the theater room are about 4 feet or 3.5 to 4 feet off the front wall. I get a huge suck out in the 80 to 90 hertz range. And the only way to fix that is either to push the subwoofers to the front wall and separate the satellite speakers and put them forward, which I can't do because these are modular, gigantic speakers. Or the other option is I could add subwoofers. And that's exactly what I did in my theater room is I added subwoofers to the system, and I got some of those SBIR effects. I alleviated them. I flattened that bass response. I filled the hole by adding more subwoofers in the room. Sealing a port will decrease the low frequency output of a loudspeaker, but also decreases headroom. So again, I don't usually like doing that. I tried doing that with the Revels, thinking maybe I could compensate for some room gain issues in here. And I lost, 8 to 10 dB of bass output when I sealed those speakers. You don't want to seal a speaker a large tower speaker with multiple drivers. Leave them open with the ports. Use EQ if you have too much gain. Flatten it out. Do positional EQ, move your seats. There's so many different things you could do, but don't crunch the dynamics of that loudspeaker if you could avoid it. Angling the toe end of the speaker can change the high frequency range levels, thereby adjusting the bass relative to the overall spectrum. This will also affect the speaker's sound stage. And so basically, if you toe the speakers in more, you'll get more high frequency energy. So it'll shift the spectrum of the sound. Maybe the excessive bass will not be as bad in that case. Or you could use tone controls. There's nothing wrong with using tone controls. I know people always scoff at that, or audiophiles scoff at that. But as long as you have really linear speakers, there's no reason why after you have everything positioned and you have everything dialed in with your seats and the speakers are towed in properly and you have the right sound staging going, there's no reason why you can't adjust bass or treble up or down depending on the recording, depending on your taste. Don't be afraid of tone controls and don't be afraid of EQ. EQ is, especially in the digital domain with PEQ, very useful tools for bass frequencies, and shelving filters for anything above the room transition is also a very useful tool. As Scotty says, the right tools for the right job. So keep all these tools in your bag of tricks. Guys, I hope you found this video useful. If you like this video, please hit the thumb up, hit subscribe. Don't forget about our Patreon channel at patreon.com/audioholics. We appreciate your support. You get direct access to me if you want to suggest video topics. Give me some comments down below if you want to see this topic explored and more thoroughly. Maybe I'll bring on some guests. Maybe I'll bring on Anthony Gramani. Maybe I'll bring on James Larson. I'll bring on other guests in the industry. We could talk more about speaker boundary interference. We could talk more about room gain. We could talk about more of the benefits of calibrating multi-sub. I need the comments down below. You guys have to create the demand for the content. That way we prepare it for you. So with that said, I hope you guys enjoy. And until next time, my friends, keep listening.